If you're already familiar with the first law of thermodynamics, then the next step would be to go over PV diagrams. Welcome back to day 23 of MCAT 528 and 28. Today's important topic will be about the 4 common types of pressure volume diagrams. First up is isobaric, meaning constant pressure. This will result in a horizontal line known as an isobar, with an area under it representing the work. This is because work is equal to pressure times the change in volume, which is base times height. Note that this is the work done by the gas, so if we plug it back into the first law of thermodynamics, where the internal energy is equal to the heat times the work done on the gas, we would have to change the W to negative. Next up are isothermal processes where the temperature is constant. Now, according to kinetic molecular theory, the internal energy is directly proportional to temperature. Therefore, if the change in temperature is equal to 0, the change in internal energy must also be equal to 0. This leaves us with the heat being equal and opposite in magnitude to the work done on the gas. The isotherm represents an inverse relationship between the pressure and volume. And note that the change in pressure times volume is equal to 0. This is because of the ideal gas law where PV equals nRT. Since in isothermal processes, nRT is constant, PV must also be constant. Our third process is isochoric, also known as isometric, also known as isovolumetric. This is represented by a vertical line, meaning that there is no area and work is equal to 0. Therefore, the change in internal energy is directly equal to the heat. And finally, we have adiabatic processes, where there is no heat transfer. This is also represented by an inverse graph, but it is steeper than the isothermal. In this case, since the heat is equal to 0, the internal energy must be equal to the work done on the gas. A final point that I want to make is that looking at the Carnot cycle, if you go from left to right, it is known as expansion, and right to left is known as compression.